Okay, so let me know if my voice and my screen is visible.
Yes, it is visible, sir.
Okay, so good evening. My name is Abhishek. I am a PMRF research scholar from Department of Mechanical Engineering, IIT Guwahati. So I welcome you all to the week 12th of the live interactive session for the course IC Engine and Gas Turbine. Okay, so we have already covered previous 11 weeks where we have gone through the first IC engines, all the parts of IC engine and the major processes and the major cycles that are involved in the IC engine. And based on that, after that, we went on to gas turbine, and we have already seen different parts like compressors, turbines, and now we today we'll be seeing the nozzle, and based on that we'll be solving few multiple choice questions and numericals. So if you have any doubt, so I can see that the exam is already scheduled on April 24th, if I'm not wrong. So based on that, if you have any doubt, you can directly write a mail on this Gmail ID. I'll be happy to answer you. And if you have missed the lecture, then you can get the recorded version of these sessions from this YouTube channel. Okay. So we'll go ahead with this. So in this week, if we go to the summary, it was all about the turbines. The radial turbines was introduced, although was not gone through. It was not discussed in detail because we have already discussed the axial turbine. Okay. So all the functionality stays the same. Whatever the parts are present in an axial turbine are also present in the radial turbine. The only difference is that here the flow takes place in the radial direction. Okay. So the fluid enters axially, but it exits radially. But in case of axial turbine, we were always the inlet and the exit were axially. Okay. So based on that, you can solve few numericals. There was not any question discussed in our lectures. So we will also go ahead with that. And after that, lecture number 40 in lecture number 47, we saw the nozzle. And if I say the most important formula for in the nozzle is, let me see. Okay. So in case of nozzle, if you see the most important formula that we saw was 1 minus m square dv by dA. Sorry, I write in the other way. dV by V is equal to minus dA by A. So this was the important formula that was covered in this slide in this lecture number 47. And in this through these equations, it was mostly although the derivation was not done in this lecture, but if you go to the deeper of gas dynamics, so you can find that this is derived from the continuity equation. That is, you can derive this from the continuity equation. Okay. Now in this, if you see, m is the Mach number, and the Mach number is nothing but the velocity of any fluid with respect to that of sound. Okay. We this is a reference is a way of referencing the speed of any fluid. If the speed is above the sound velocity, we say it as supersonic velocity, supersonic flow. And if the flow is less than the sound velocity, then we tell it as subsonic flow. Okay, and V is the velocity, and A is the area. Now, always we have a notion that if there is a nozzle has a converging section. This is what we always assume, and we always feel that as the area is decreasing, of course, the velocity will increase. This has come from our continuity equation where rho AV is equal to constant. Okay, but this is the incomplete part of it, because in this case we have considered many other things like the area, the velocity is below the subsonic. Okay, so here if you see if the area increases, velocity will decrease, and the vice versa. But in case of when the flow is taking place in supersonic condition, you can find it from here. See, let us say it is supersonic. The flow is supersonic. That means m is greater than 1. Mach number will be greater than 1 because the velocity of the flow is greater than the velocity of the sound. And based on that, you will be finding that you will get a negative sign here. You will get a negative sign here. And if you get a negative sign here, that means dV by V, this ratio is directly proportional to dA by A, which says that the velocity will behave in the similar way as that of the area. That means as the area increases, velocity will also increase, and if the area decreases, the velocity will decrease. This takes place in case of supersonic flows. But when it is subsonic, subsonic, we'll find that whatever we have known from earlier, the flow will take place in the similar way. Like for example, if it is subsonic, okay. Okay, so if we are going with subsonic flow, here we will find that m is less than 1. Okay, so if m is less than 1, we found that this part will be positive, and thus there will be a relation where the ratio of dV by V is inversely proportional to the area, change in area. Okay, so what does this suggest? That whenever the area will reduce, area will be inversely proportional to the velocity in case of subsonic flow. So this was very well discussed in lecture number 47. And after that, two important criteria are like intake efficiency and nozzle efficiency was discussed. You can go through the lectures, then you can able to find out what are them. But as I can say that intake efficiency is generally taking place whenever there is a gas turbine or whenever there is an aircraft. Will be always be having, when we discussed ramjet and scramjet, I discussed a process called ram effect. I hope you remember this. So what is ram effect? Ram effect is a way of changing the velocity of the flow to the pressure energy. Okay, because when we are flying at a very high velocity, let us say the velocity is very higher than the sound and it is in supersonic case. So in that case, what we are doing is we are trying to change the velocity into the pressure, so that this pressurized gas is this pressurized fluid will be easier for us to atomize the fuel that is taking place in the combustion chamber. Okay, so that is why in ramjet you won't find any compressor, because the ram effect is enough to get the pressure in case of there is a portion called ram. Okay, this is nothing but just a an obstacle which will try to reduce the velocity, and that velocity will be getting converted into the pressure. Okay, we have very well discussed this in the lecture types of aircraft engines. There you will be finding that there is a term called intake efficiency. This is the TS plot. So this will be constant pressure lines. So earlier in intake efficiency, our aim is to reach to this pressure. Let us say this pressure is P01, but we are reaching to P01 dash, because there will be losses. In ideal case, you can reach to P01, but in actual case, you won't be able to reach to. Okay. The temperature will be staying constant. Let us say this is the temperature T1. Okay, so in this case, what you will be finding is you won't be able to reach to the same pressure. There will be some pressure loss due to friction and other losses or shock. So you will be seeing a decrease in the pressure that is achieved, and you will be reaching to a pressure P01 dash. Based on that, you can find the ram efficiency or the intake efficiency. Okay. Now, similarly, we can go for nozzle. The main function of the nozzle is to expand or to reduce the pressure. Okay. So if initially it was at this temperature, let us say that is T1, and this is let us say this is Ts and this is Ts dash. So in nozzle efficiency, what you will be finding is we wanted to reach to a temperature through expansion, that is Ts, that is through ideal case, but due to the presence of different inaccuracies and different losses, we won't be able to reach there, and the process won't be isentropic, and we'll be reaching here. This is S, of course. We'll be reaching as Ts dash, and based on that, the nozzle efficiency is denoted by the actual change in kinetic energy to the ideal change in kinetic energy. So if you solve more and more numericals, you will be very much clear about all this usage of all these terms. So this was all about discussion in lecture number 46 and 47. This was the summarized portion. The more details you can find in the lectures. Now we'll go on to solve few multiple choice questions and few numericals. Okay. Okay, let's start with the first question. I hope my voice is clear.
Yes, sir.
Okay. Okay, so first question is select the appropriate airflow pattern inside a gas turbine based aircraft engine. So we have enough time today, as there were very few lectures that was covered in this week. So I am giving you enough time. So try to answer this question.
Sir, option D.
Option D.
Yes, sir.
Yeah. So the correct answer is option D. Select the appropriate airflow pattern inside a gas turbine based aircraft engine. So first you will be finding out okay. So first you will always be finding out the RAM that I said just now, whose initial function is to just provide the initial pressure rise. Then you will be finding a compressor, which will do the rest of the compression. This is the compression. Then you will be finding the combustion chamber, where the combustion will taking place, and then there will be turbine. Now this turbine, if you talk about the turbine based aircraft engine, so there are if you see in case of, we have already solved a few numericals where you will find there are different stages of turbine, or there will be two turbines. So the first turbine will be driving the compressor, and the second turbine will be producing electricity, but that is in case of in power plants. But when you find it in case of aircraft, the turbine's main function or the only function is to run the other power driven system like compressor, or if there is a fan. Okay, so all the works of the turbine will be used to run this compressor. Okay, now after that there will be a nozzle which will be providing us the thrust. Okay, so this is the cycle, and the correct answer is option D. Coming to question number 2, which one of the following is correct for the function of the intake used in subsonic aircraft?
Sir, option A.
Is it? No. Think it properly. We have already just now covered this one. See, thus when will you will find this shock? If you had gone through these lectures, then I think you would have known what is a shock.
So shock will appear in above the Mach number 1.
Correct. So, but in the question, what is it saying? Subsonic
Function of
aircraft, right?
yes, sir.
So, will the option A be correct? It won't be correct, no. So think properly.
So raise the kinetic head of air at the engine entry of the engine.
But what is the use of kinetic head? See, what is kinetic head? Just tell me. So tell me what is kinetic head. Do you know Bernoulli's equation?
Yes, sir.
So in that we use the term called head. Okay. So what do you mean by head? Why do we call them head?
Because it's the starting point.
No, actually, it head. See, based on head, we want to denote in case of meter. Okay, the unit or the dimension we want to denote is L. That is why we call it as head. But when you talk about kinetic head, which we represent by c square by 2g. Okay, but do you find what is the intake? What do you mean by intake? Intake efficiency means you are talking about a device called RAM. Okay, so what is the function of a RAM?
Mm.
What is the function of a RAM? Does RAM increases the kinetic head or increases the pressure head?
Increase the pressure head.
Yeah, correct. So RAM's function is it increases the pressure head, and nozzle's function can be either of this. Either it increases the kinetic head or decreases the kinetic head, different depending on its shape. Okay, so the correct answer is option C. Rises the pressure head of the air at the entry of the engine. Correct? Do you want? Did you understand?
Yes, sir.
Okay. Now coming to sorry, question number 3. In a ramjet engine, air enters from intake with dash speed and undergoes combustion with dash speed in the combustion chamber.
That's option C.
Option C.
Yes, sir.
So what do you think? If you, I think you are present in the aircraft, the different types of aircraft. You asked me the question of scramjet and ramjet.
Yes,
So
sir.
what I told what is the function of a ramjet engine? What is the application it is being used? What did I say? What are the applications in which ramjet are used? First of all,
Super,
tell me. Yeah,
it is used for the supersonic conditions.
correct. So supersonic condition, that means it will it will be encountering the air that will enter the that will at what speed? It will encounter air at what speed? You are telling it's
About
supersonic.
Mach number one. Yes,
Correct.
sir. But
So
the
yeah, but the
but before the compression, it should be subsonic.
but is it asking whether it is so before the combustion or
Um,
after before the compression or after
no,
the
no,
compression?
no, sir, no, sir.
What does
Intake.
it say?
It's
Correct.
intake.
Yeah.
Intake means supersonic and subsonic.
Yeah. Correct. And
Com-
what happens in the combustion?
It is subsonic.
Correct. So the correct answer is supersonic and subsonic. Just I will repeat what is the concept in a ramjet. So in a ramjet, you will it is not a it is a pilotless engine. Okay, you won't find any. It will be actually what will be done is there will be an aircraft which will already be in that particular speed. Let us say speed with a velocity more than the Mach number. It will be providing its initial velocity to a ramjet engine. Okay, and that velocity and generally you will find this in use of military military or missiles. Okay, military aircrafts or missiles, and in that case you will be finding the air enters the intake with a velocity more than the Mach number, more than the Mach number of 1, and then that velocity is used to rise the pressure. Okay, so you are right, absolutely right. It will enter at a supersonic speed, and the combustion will be taking place at a subsonic speed. Coming to question number 4, for the fluid flow through a nozzle, what happens? So this is a very, if this question I tell you in overall, uh, this question more is not totally right or totally wrong, but just consider that nothing is given to you. Just a generalized question. So tell me what is the answer.
The pressure will decrease and velocity will be increases.
Okay,
Low.
but when is that? Subsonic or
Yeah?
supersonic?
And both conditions.
Both condition.
I think so.
How? Just now I discussed, right, that through this formula,
Yeah, it's the
1 minus m square dv by v
dV.
minus is equal to minus dA by A. So how do you say that every time there will be a reduction in velocity or there is an increase in velocity? It all depends on the flow, right?
Yes, sir.
Yeah. So tell me based on that.
So for subsonic condition, the pressure will decrease and the velocity will increase. So
For subsonic
and
condition, the pressure will
decrease and velocity will be increased.
correct. So
And
is there any option?
pressure. So not exactly the option is there, but mention always decreases.
Yeah. So that is all about option A. But when you go to option B, what does it say? Pressure increases when the inlet flow is subsonic. So in subsonic, pressure will increase or pressure will decrease?
Decreases, sir.
Pressure will decrease because the velocity will increase in subsonic case. So option B is not correct. Option A is not correct because it won't be always. There won't be any term called always. Okay, it all depends on the flow. So now coming to option number C, velocity always increases but pressure remains constant. Will
Yes, sir.
this
For
fit?
supersonic condition, it can be.
Correct. So option D is correct because velocity decreases in case of a flow when the flow is supersonic. You'll be finding that if there is a nozzle and it is a convergent nozzle, you'll be finding that the convergent nozzle means minus dA by A. So area is decreasing. Okay. Area is decreasing means this will be negative. So you will find that the total will be positive. Now 1 minus m square dV by V. Now in supersonic case, this will be again negative. So now you got to understand that you will be finding a okay. Okay, so this sign is already representative. That means the sign is already taken into the consideration of the decrease. Otherwise, it will be just there won't be any sign. This is just dA by A, and if the area decreases, that means it will be minus. So considering that this will be negative, and in case of supersonic, you will find that this is negative. So negative will cancel on both sides. So dV by V will be positive, and you will find that as the area decreases, you will find the velocity will also decrease when the flow is supersonic. Okay. Coming to question of 5, which of the following statement is valid for a scramjet engine? I think this you should know the answer of this. Scramjet is even faster than the
Ramjet.
ramjet. So it will be obviously the fluid that will be entering the free stream will be in supersonic condition. Now the next thing is whether the combustion takes place in supersonic or subsonic.
So it will be in both conditions in some cases. In some cases it can be subsonic or it can be supersonic.
Okay. So based on that, in which option do you think is the correct? Actually, mostly you will find it in supersonic. The velocity of entering and the combustion both will be taking place in supersonic condition. So option C. I think C is the correct option. Yeah, C option C is correct. Okay.
Yes, sir.
Now coming to question number 6. Choose the appropriate sentence for the fluid flow through the varying area ducts. Just again, same type of question. Just try to answer.
Sir, I think option D.
Question number 6. Okay, choose the correct answer, appropriate sentence for the fluid flow through a varying area ducts. So now we are talking about converging, diverging type of nozzles. Okay, so converging duct always function as a nozzle if the intake is supersonic. Okay, is it true?
No, sir.
Okay, so in case of a supersonic flow, the area, the the change in area will be similar to that of the velocity. The change in velocity and the change in area will be following the same. Will be following the same relations. Okay, so that means in a supersonic case, if you find that the converging, it is a converging duct, so as the area will decrease, so the velocity will also decrease. But in case of subsonic case, you will find it to be opposite. Means in a converging, the velocity will increase. So based on that, if you see the converging duct always functions as a nozzle if the intake flow is supersonic. No, this is not correct. Converging duct always functions as a diffuser if the intake flow is subsonic. Okay, so is this correct? So this is not correct because it won't function as a diffuser. Diverging duct always functions as a diffuser if the intake flow is supersonic. So is this correct? Because now the area is increasing and the flow is supersonic. So you will be finding that the velocity will increase. So it won't
Increase.
function as, yeah. So it won't function as a diffuser. Then the diverging duct function as both as diffuser or a nozzle, but it depends on the intake Mach number. This is absolutely correct, and it considers both the cases. Okay. So you also told option D, right?
Yes, sir.
So next, when the inlet flow through the converging duct is supersonic, the pressure dash while the velocity dash along the length of the duct. Converging duct. So two key words. First is in it is a converging duct, and second is the supersonic.
Sir, option C.
Option C. So it is a converging. That means if area reduces, velocity will also reduce.
Reduces.
Okay. So if velocity reduces means pressure will increase. So option C is correct. Now coming to question number 8, the flow at the minimum cross-sectional area of the choked convergent divergent nozzle should be dash for a particular reservoir temperature and pressure. This you tell me. This although this I didn't cover in case of our summary, but it was already covered in the lecture. So just based on that, just tell me what is the answer. What is a choked flow condition?
I think subsonic, sir.
It's not subsonic, it is sonic. Okay. Just go and refer this lecture. You will be finding that you will there is a minimum cross section of this area in case of a converging diverging nozzle. Okay. So this is the minimum area, and here you will find that there is a condition called choked flow condition, and that takes place when the flow in the flow at the minimum cross section area is sonic. Okay. Now coming to question number 9. The flow through the nozzle is considered to be overexpanded when the nozzle outlet pressure is. This also is covered very in depth in the lecture number 47, towards the last part of the lecture. What is an overexpanded flow? And in that case also, in particularly that section, you will also find this, the choked convergent divergent nozzle. So tell me, what is the answer for this? The flow through the nozzle is considered to be overexpanded when the nozzle outlet pressure is.
I think option D, equal to the reservoir pressure.
Sorry?
Option D, equal to reservoir pressure.
No. This is a particular case in overexpanded. As the name suggests, the pressure that you will be finding is lesser than the ambient. Okay. Just refer to this lecture, where you will be finding there is a graph somewhat like this. This is P, and there will be some conditions like this is a converging section, this is a diverging section. You will be finding that the pressure is reducing, then again increasing. Okay, but there will be a case where you will find that pressure will reduce, and in that case, when the flow is entering at sonic, here Mach number is equal to 1, you will be finding that the pressure that is achieved here at the end of divergent section is less than the ambient. Just refer this lecture, you will find it very clearly. So in that case, this is generally called as overexpanded condition. Okay. Now, coming to question number 10. Which of the following expression provides the correct area Mach number relationship for a variable added? We have discussed this multiple times. Just tell me.
Sir, option A.
Are you sure? Just see the. I think you are still.
No, sir.
Yeah.
Option C, sir.
Option C.
C.
Option C. Are you sure?
Yes, sir.
No. You are again getting confused with sign. There is a negative sign, right?
Yes,
But
sir.
are you
But
finding a
mine,
negative? Yeah. So
no,
you are
sir.
not finding a negative sign. So that is reflected in terms of, we have written, whenever I wrote the formula, it was 1 minus m square. But here, when you include a negative sign, that will be m square minus 1, right? Option B
Very
is correct
correct.
answer. Isn't it? Did you get?
No, sir. No, sir.
Yeah. Just take your time. Now did you get, or still you are not able to understand?
No, sir, I didn't get.
Huh? Sorry?
I didn't get, sir.
Yeah. Okay. So how did I write the formula? 1 minus m square.
Of dV by V
Yeah.
equal to minus
Minus.
dA by A.
Correct. Okay. Now just bring this 1 minus m square here on this side. This minus 1 minus m square
Root D
dA by A.
minus V.
So what is 1? If you take minus inside, what do you get? Isn't it m square minus 1?
Yes, sir.
What is the problem that you are facing? Now
Yes,
did you get?
yes, I'm little weak in mathematics, so
No problem. Okay.
yes, sir.
Yeah. So option B is correct answer. Now coming to question number 11. In an axial flow compressor, the absolute velocity in the stator.
So option D remains constant.
In a stator,
Yes, sir. The
what is
pressure
the
will
function
not.
of this? What is the function of the stator? Just tell me.
The velocity and the pressure will be say will be
Will be
constant side. It will constant. Will there is no change in pressure and velocity.
how do
Oh,
you
no,
say
sir.
that?
The velocity will be decreased and pressure will be same.
Correct. Pressure will not same. It will increase. So
Yes,
see, there is a conversion between this kinetic and pressure head. So you are converting the kinetic head, that is the velocity, into the pressure. So if you are converting something, then what is happening is that you are decrease the velocity should decrease and the pressure should increase. Did you understand?
yes, sir.
So the axial flow, the absolute velocity, that you are talking about the axial velocity. U and CA will stay constant in case of an axial compressor. That is an important question. Yeah, that in that case is right. But here it is asking about absolute velocity.
Okay,
Okay.
sir.
So
Okay,
here
sir.
you find there will be a decrease in the absolute velocity in the stator. Okay.
Okay, sir.
Now tell me the next question. In the axial flow compressor, the absolute velocity in the rotor.
Increases.
Yeah, correct. Increases because it is a rotor. The main function of the rotor is to impart the kinetic energy to the fluid. Okay. Okay. So the other one is present or he left. Okay. So he left. No problem. Now question number 13. Tell me the degree of reaction is defined as we discussed in last lecture.
Sir, option A.
Option A, actual enthalpy in the enthalpy change in the rotor by the actual enthalpy change in the stage. Yeah, correct. Option A is correct. So this is all about the MCQ questions. Now we'll be solving few numericals based on the our axial compressors, and I think two are from axial compressors and two are from centrifugal compressor, and that will complete. There is no such questions in nozzle based on whatever things that are covered, but please refer to this equation. I think based on that equation, many questions can be framed. So take care of that equation properly. Okay. So let's start with this question. This time giving you few minutes, you just read this question and analyze what are the things that it has given and what are the things that it has asked. Okay.
So they given the inlet pressure and temperature and
Okay.
the velocity of the air,
Okay. What
and they
velocity?
said air
Be very.
velocity,
What velocity? See
axial
there.
velocity of the air.
Correct. So yeah, that needs to be very clear. What is because there are three different velocities. One is relative velocity, one is axial velocity, another is the blade velocity. So you need to be very careful.
Okay, sir.
Yeah. So go on. Yeah. Tell me what are the things
And they
given
said, there are no inlet guide vanes.
and what does that mean?
Inlet guide vanes.
So if there is a guide vane, then what will be happening to the flow? Just I think I covered this last to last class. So just think if there is no inlet guide vane, so the flow will enter. Will it enter smoothly onto the blades or it will directly strike the blades?
Directly straight.
So if it is striking directly to the blades, what part of velocity will the blade be facing?
What?
See, one is the relative velocity, another is the absolute velocity of the flow. Okay, these two velocity are the velocity of the fluid. So if
Okay,
there are
fine.
no guide vanes, so the absolute velocity will be perpendicular to the blade. That
Yes,
means
sir.
alpha will be 90 degree. Correct?
Yes, sir.
Yeah. So go on. After that, what do you understand from the question?
And the rotor rotor
So that
stage has a tip of diameter 60 centimeters, sir, and half diameter is 50 centimeters.
correct,
And it rotates at 100 rotation per second.
correct.
And here enters the rotor. And there is no change in velocity and radius of
Yeah.
the
So
air and the
yeah. So this sentence is also very important. What does that mean? So the air enters the rotors and leaves the stator in axial direction with no change in
no,
velocity or
velocity.
radius. What does that mean? Did we discuss a thing called free vortex? Free vortex because see whatever velocity triangle that we draw are generally considered at the mid height of the rotor or the stator. Correct? We do that, and if that is if for example if I ask you what is the velocity triangle at the tip or what is the velocity triangle at the mid, so both velocity triangle will be differing, but through this sentence we got to know that we'll be only considering at the mid depth. Okay, so there is no change in radius, so we don't have to worry about the change in the whirl component of the velocity, because in case uh, in case of free vortex condition you will be finding that this was the condition, right? Cw1 r1 is equal to Cw2 r2. So here we are not changing R1 and R2. That means we are considering at a particular depth, and that is the mid depth. Okay.
Okay,
So
sir.
you understood that. So and the next question, air is turned through 30.2 degree as it passes through the rotor. So there is a deflection of 30.2 degree. What does that mean? Tell me, what does that mean?
I
So
couldn't able to explain.
sorry.
I couldn't able to explain, sir.
Okay, so that means, see, let us say there is the angle of the blade is x. In case when it enters, when the blade flow enters, when the fluid is flowing, so the let the blade angle is x. That means beta 1 is equal to x. And if there is a deflection of 30.2 degree, that means at the end it will be x minus 30.2. Now did you get? So the total deflection between beta 1 and beta 2, the difference in the angle is 30.2 degree.
Okay,
Okay.
sir.
Now assume a stage pressure ratio of 1.2. So what does this mean?
So between the each rotor and the stator,
Hmm.
each, each stages pressure ratio is 1.2.
Correct. So in each rotor and each stator, that is a particular stage, and that there we find a pressure ratio of 1.2. Okay. Now assuming the constant specific heat and that the air enters and leaves the blade at blade angles, correct? Construct the velocity diagrams at the mean dia of the for this stage. Okay. So if you want to draw the velocity triangle, let us say this is the rotor blade. Now things that we got to know is, so this is v1, that is the relative velocity, and this is c1, which is also equal to ca, that is the axial velocity. Okay, this is beta 1, this is u1. Here there is no concept of u1 and u2 because this is an axial compressor, and you will find that u1 and u2 both will be same. Okay, did you get what is the how did we draw the velocity triangle in case of inlet?
Yes, sir.
Okay, so now we are coming with to the outlet. So in case of outlet, how do you expect it to be? It is, yeah. So this is a rotor. That means the velocity, the absolute velocity will increase or decrease. It will
So it says remains constant.
absolute
That's not
velocity
it.
again.
Okay, okay, okay. It will change, sir.
Yeah. So it will increase. So this is C2. It has increased, and this is the B2. Now this time this is the CA. This is constant. The axial velocity is constant, and this is U. Okay. So the velocity triangles you have drawn at the mid depth. Now come to the, what is the formula for mass flow rate for an axial compressor? It is pi by 4 T1 square minus
D2 square.
T2 square into CA into density. at the row 2 at the exit. So what all things do we have? Now do we have CA? CA is given axial velocities 150 meter per
50 meters per second.
Yeah. And what all things are given?
Diameter of the rotor stage and half diameter.
Yeah. So from that diameter, what do you think? Why was the diameter given? You need to find out U. What is U? You tell me. Pi, dm. Dm is the mid depth. N by 60. But here N is already given in second RPS, isn't it?
Yes, sir.
Yeah. So find out pi. How to find out dm? Dm is 0. How much is the? It's 50 centimeter. I think 50 centimeter and 60 centimeter. So just take in meter 0.6 plus 0.5 by 2 into n is 100. Find out how much is it.
So 172.78.
Okay, let me check. 172.78, correct. So what is that? That you got as 178. Sorry.
172, sir.
Yeah. 172.78 meter per second. So you got. So it has asked row 2. How to find out row 2? We solved similar type of question in case of centrifugal compressor. How to find out row 2? You need to have P2 by RT2. Do you remember or not?
Mhm.
This type of question we solved last time, right? P2 by RT2. So do we have P2? We have P1.
T1.
1.0
1.0132.
013. It is ATM, atmospheric pressure 0132 bar. So what will be P2? It has given stage pressure rise, right? So just multiply
Yes, sir.
1.2 into 1.0132. How much do you get?
1.21.
1.21. Correct. 1.21 bar. Okay, so P2 is done. Do you have T2?
Yes, sir.
Do you have T2? Are you?
Yes, sir.
We don't have T2. So how to find out T2? We have T1.
T1 and T1, T2.
Okay. What do you? How to find out?
T1 by T2 equal to P1 by T2 power gamma by gamma minus.
T1 by P2 by T1 by T2. But in that case, what do you will get? Will you get T2 or you will get T not 2?
T2.
Okay. So T1 is 288 Kelvin. Now find out T2. How much are you getting? 288 into 1.2 to the power 0.4 by 1.4. Calculate.
So 303.4.
303.4. Yeah, I'm also getting that. 303.4. So put all this and find out what is rho 2. 5, 37 into 303.4.
So 1.389.
1.389 kg per meter cube. Okay, so now find out m dot. You have everything.
I'm getting 99.81.
99. Okay, let me check. So no, I'm not getting that. Just check your calculations again.
So
Just check your calculations again. I'm getting something else. 5 by 4 is 0.785 into 0.6 square minus 0.5 square into 150 into 1.38.
so I did minus there for D1 minus D2. I did plus.
Okay. I already wrote like d1 square minus d2 square.
As
P let minus dt. Yeah. Yeah, no problem. Just go ahead. Just do the calculation.
17.99.
Correct. So you are getting 17.99 or 18 kg per second. So second bit is done. Now the third bit. Third bit is power required. What is the power required formula for an axial compression? P is equal to how much? Psi sigma u Ca then tan beta 1 minus tan beta 2. Isn't it? Is it the formula? Hmm? This one will get in kilojoule per second. Just multiply m dot. Okay, so this is the formula. Do we have beta 1 and beta 2? Do you have that? We don't have. So we
Yes.
have to find out. So how to find out beta 1? Beta 1 is nothing but tan inverse of u by C1. Am I right?
Yes, sir.
This is beta 1. So tan beta is u by u1 by C1. Okay, or
Okay,
CA.
sir.
So just find out what is beta 1.
Sir, 49.03.
49.03. Let me check here. 170, 172.7. 49.03. It would be better to convert 03 into minutes, but no problem. This much degree. And how to calculate beta 2 now? Tell me how to calculate beta 2. And
Sir,
didn't he tell you? Yeah, tell me.
beta 1 minus 30.2 degrees.
Correct. So find out beta 2.
18.83, sir.
Correct. 18.83. Now, will you be able to find out? I think everything you have. You have, CA you have, psi and sigma, if nothing is given, take it as 1 and 1. M dot you have. Calculate power. Tell me in kilowatt.
Sir, what is in dot, sir?
Sorry?
In dot.
Huh.
In,
M
sir,
dot
is
is
M or N?
M.
M,
This
okay,
is
sir, it reflects N.
sorry. Okay.
It looks like on the psi value.
It is M. Psi and
Oh, sir.
sigma, if nothing is given, take it as 1.
Okay, sir.
How much you are getting?
I'm going, sir. So can show me the tan value. So beta 1 and beta 2 values. So 378.13.
Yeah, 378.13 kilowatt. 378.13 kilowatt. What is the next bit asking? Degree of reaction. What is the formula for degree of reaction in case of an axial compressor?
So CA divided by 2U into tan beta 1 plus tan beta 2.
Yeah, correct. Absolutely correct. So find out everything you have. What is the degree of reaction?
So 0.64.
0.647. So let us say 0.65. Okay.
Okay, sir.
Did you understand the problem?
Yes, sir.
Okay. So just it's all about knowing the formulas, and based on that, how to calculate U. You either you have to take the help from the other relations that you have learned, or you have to take the help of a velocity triangle. Okay, that's all about it. Then let's see question 15. Another question from the axial flow compressor. An axial flow air compressor of 50% reaction design has blades with inlet and outlet angles of 45 and 10 degree. So what does it? What has it given? So it has given 41, 45 degree, and beta 2 is 10 degree. Okay. Now just think about this question and tell me what how to find out what is the approach. You should know the approach. Yeah. Go on. All the formulas that we used in the previous question is applicable in this question as well. So just that was a hint.
Okay. So what should we need to find?
What has it has asked?
And so first what we have to find first.
C. Okay, just tell me what are the things that are given.
Inlet and outlet angles and the pressure ratio, overall isentropic efficiency and static inlet pressure temperature. And the blade speed and axial velocity are constants throughout the compressor. And they said
Blade speed
assuming the
and axial
value.
velocity, that itself is a character of an axial flow compressor, though that is just an additional sentence.
Okay.
Okay. So the overall
Okay.
isentropic efficiency is given and the inlet static temperature is given. What does that mean? It has given T1, 37 degrees Celsius. And what does that mean? 37 means how much it is? 300 or 310.
सर एक्चुअली मैं लेट ज्वाइन किया हूँ तो ये आईसी इंजन गैस टरबाइन किया है ना
जी, ये आइसेंस एंड गैस टरबाइन की है।
Thank you, sir.
Hmm. Okay, so the compressor, the total pressurized delta P pressure, let us say right like this, pressurized is 6:1. So that is the total pressure, not a stage pressurized. And I have already said you that in axial flow compressor, we will be having multiple stages. Because in a single stage, the pressurized won't be more than 1.2, the pressure ratio won't be more than 1 to 1.5. Correct. So it has asked the what is the find the number of stages required if the work done factor is unity. What is the work done factor? Psi. Okay. One, it is for two cases you have to find the what is the number of stages. If it is unity, you have to find out. If it is 0.87, then you have to find out. In both the cases, you have to find out what are the number of stages needed so that we will be able to achieve a pressure ratio of 6:1 with all these conditions given. Okay. This is all about the question that it has asked. So just go on. Assuming a value of 200 meter per second for the blade speed. So U is also given, that is 200 meter per second. Okay, just think. As I said, you the okay. One more important thing is given also the react. First of all, the reaction. The reaction degree of reaction is 0.5 in this case. Okay. So based on all the formulas that I used in the previous questions, that will be applicable here as well, and then additional formula will be applicable that will solve this question. So you know everything, all the things have been discussed. Just go on. Just try to solve this question. I'm giving you some 3 to 4 minutes. Tell me your approach, then we'll go to solve this question.
So we need to find the axial velocity.
You need to find out the
Axial
axis.
velocity.
Correct. So how to find out? Just a second.
So you can find from the degree of refraction and the tan and beta 1, beta 2 values.
Tell me how to find out axial
So
velocity.
we have degree of reaction and beta 1, beta 2 values. From that
Absolutely.
we can
Very good. Yeah. So we have degree of reaction. Just go on. 0.5. What is the formula? U by
u, u by tan beta 1 plus tan beta 2.
is CA by 2U, right? I'm writing opposite. You are not saying anything. Okay. Now
Yes,
to
sir.
find out U is given. Can you find out CA? Just find out.
I'm getting 170.02.
Okay, let me check. 170.02. Yes, I am getting that as well. 170.02. Correct. Will be meter per second. Okay, so that thing is done. So how to find out number of stages? This you are right. Your approach is right. What is the next approach? How to find out the number of stages? You find out the stage pressure. What is the temperature rise in each stage? Then, if you divide that with the overall temperature rise, you find out this one, and if you divide this by this, you will get the number of stages, isn't it? How to find out the each temperature rise in each stage? What is the formula?
I don't know, sir.
Is it very? This is very simple. P is Cp T03 minus T01, which is also Cp delta Ts, isn't it? Do you know this formula?
No, sir.
How? This one I said, right? Whenever you were talking about any compressor or a turbine, how do you find out work done? Cp delta T.
I think I forgot this, sir.
Okay, so Cp delta T. Okay, so T delta from here, this is also equal to psi sigma u Ca tan beta 1 minus tan beta 2. Isn't it? This is also P. At least you should you know this one. We just used this formula in the
Yes,
previous.
yes, sir.
So when you equate these two, can you find out delta Ts?
Okay, yes, sir.
Sigma is not given. Just take that as 1. U Ca tan beta 1 minus tan beta 2 in this bracket by Cp. Find out what is delta Ts. You first, for one case, you have to take psi as 1, and the other case, you have to take psi as 0.87. Find out in both the cases. Let us say start with delta Ts1, delta Ts2. Tell me.
So I'm getting 22.42.
Okay, let me check. Yeah, 100, 200. How much you are getting? 20?
22.42.
I'm getting 27.86. Just check your calculation. I'm also rechecking the calculation.
Okay, sir. as a 27.86.
Correct. I'm also getting that 27.86. This is Kelvin. Find out for just multiply psi in this case, then you will all 0.87, then you will be finding for the second case. How much you are getting? Are you getting this?
I'm doing so.
Just multiply psi on the previous case, no? It's psi is 0.87.
Yes, sir. Yes, sir. 24.50.
So that task is done. Now the overall it is asking, let us say there are n number of stages. So we are trying to find Tn minus T1. Okay. So if I take, and the overall pressure rise is given 6:1. Okay. So how can you write Tn in terms of T1?
So what is TN?
Tn is the temperature at the end of the nth stage. We don't know number of stages, so I'm marking that as n. So after n stages, the temperature rise that you are seeing in the compressor is Tn. Okay. So
Okay.
how do you
Okay,
find?
sir.
Yeah. How do you find out Tn if you have T1? What do you multiply? Isn't it?
TN of pressure is. Yes, sir.
So it will be T1 Rp to the power gamma minus 1 by gamma minus T1. Just take T1 common. Rp to the power gamma minus 1 by gamma minus 1. Okay. So ideally speaking, this should be the temperature difference, the overall temperature difference. But as there is a thing called isentropic efficiency 0.85, so just divide 0.85 here. Now find out what is the T overall.
I'm getting 244.12.
240,
4.12.
44.12. Yeah. Just let me check once. Yeah. Now divide T overall, you got 244.12. This is the overall temperature rise in the whole compressor. Now the number of stages N1 is equal to 244.12 by 27.86. That is the temperature rise in each stage. Calculate. Calculate N2 as well.
8.78.
8.76. So 8.76 I'm getting. Okay, you are taking 78. So there cannot be number of stages cannot be in decimal. So we take that as 9. So you need 9 stages to get this temperature, get this pressure when taking psi as unity. And if psi is 0.87, how much do we get? Find out N2.
So 24.24.
How much? 24.
Yes, sir.
How? Total is 244.12, and you are dividing from 24.34. How can it can be 20?
Sir, actually divide the 24. It's a 10.06.
Yeah. So let us take that as 10. Did you understand the question? How to solve such questions? How to find out the number
Yes.
of stages? This type is a very important question. So one thing that you are getting to know is that if the size 1, if there is no losses, then you can achieve the same pressure rise in one stage lesser. But if you are finding there is some losses and it is 0.87, then you need a extra stage. Okay.
Okay, sir.
Now, axial compressors, I have given these 2 questions. You can solve other numericals as well. Try to solve this. This is a centrifugal question, centrifugal compressor question. I think such questions we have already solved. So try, give it a try. Are you able to solve?
I'm trying, sir.
Sorry?
I'm trying.
Okay.
Sir, do we need to find all the temperatures or just T3 or T03?
Yeah. You have to find all the temperatures. In this case, is just T3 and T03 and T01.
Okay, sir. So I just found the T03 dash and T03, sir.
Okay. So just I will tell you the approach here. So first of all, what are the things that are given? You have a Q. Q is 600 meter cube per minute. Okay, it is volumetric mass flow rate. Okay. Then N is given 10,000 RPM. Pressure ratio is given 4. And isentropic efficiency of the compressor is NC is 0.82. The outer radius of the impeller is twice that of inner radius. Neglect the slip constant. Assume the ambient air conditions. So it is T01 is 293 Kelvin and T01 is 1 bar. The axial velocity of the flow is CA is given 60 meter per second. So first of all, it is asking and is constant throughout. Okay. So CA1 is equal to CA2. Generally, we don't see that in case of the centrifugal compressor. So here it is given CA1 is equal to CA2. That is 60 meter per second. Determine the power input to the compressor. So power input to the compressor can be written as CP delta T. Okay, where Cp, this will give in kilojoule per second. Sorry, kilojoule per kg. So T03 minus T01. We have T01. We have to find out T03. How to find out T03?
I got 466.867.
So T01 into Rp to the power gamma minus 1 by gamma. Just find out. You have find out. I will just check.
Sir, it's for T03 dash.
Sorry.
This one is for T03 dash.
Yes, correct, correct. Just okay. You are correct. It is T03 dash and this is T03. Correct. Just find out T03. You already
So
find out. Just checking here.
I got 435.567.
435.39 I am getting. How much are you getting?
56.
Okay, 56. Now find out T03 dash. How to find out? You take the help of efficiency. That is in a compressor, ideal is less. So T03 minus T01 by T03 dash minus T01. Find out T03 dash from here. I'm getting 466.65.
86 I got, sir.
Okay. So now you can find out 1005 into 466.65 minus T01, 293. Calculate how much you are getting. I'm getting 174.5
36 I got.
kilojoule per kg. Sorry, how much did you get?
Yes, sir. Same answer, sir, but I got 36.
Okay. So first bit is done. Then the next bits are impeller diameters at the inlet and the outlet and the width at the inlet. Okay, for that you need to find all the velocities because you have to equate m dot is equal to pi by 4 d square d1 square minus d2 square into let us say Ca into rho 2. Either you have to do this and also you have to use for a width. You have to calculate pi dm, sorry, pi d1 w because it is asking inlet w1 into Ca into rho 2. Then also it's m dot. Okay, we don't need the rho 2 here because it is given in meter cube per minute. Meter cube it is given. So we don't need to multiply density. Okay, did you get that? If it was given in kg per second, then only we needed to multiply rho 2. Okay, so now that thing of finding P2 or those things is not needed for now, I think. Okay, are you listening?
Yes, sir.
Yeah. So now D1 and D2 you have to find out. How to find out that? That is very easy. I think you would have also thought of that. So W you find out. W is also equal to U square, taking a sleep factor as 1. Isn't it? Sleep factor and the work done factor, if you take it as 1, isn't W is equal to U square in case of a centrifugal compressor?
Yes, sir.
So you equate that one with 174.52 into 10 to the power 3 because we have to convert into joule per kg and you will find U. Just find out how much you are getting in. I'm getting 417.75.
So 418.84.
Correct. Correct. Okay. 417 I'm getting. No problem with that. So once this is the U2. Now U2 is also equal to pi d to n by 60. Isn't it?
Yes, sir.
Find out d2. N is given, 60 is given, U2 you have. Find out.
I'm getting 0.79.
Correct. So let us take that as 0.8. D2 you are getting 0.8. We have relation that D2 is twice of D1. So how much is D1 then? 0.4 meter. Isn't it?
Yes, sir.
So you got inlet and outlet diameters. Then the width at the inlet. So you need to find out. If I just not write m dot, just let me write its q. Okay. You have CA. Just find out W1. Remember to convert from meter cube to minute to meter cube per second.
Meter cube per 2 seconds, sir.
Yeah, because let's do it in SI units. So it is given meter cube per minute, and you all have everything as meter per second because the velocity that you
Yes.
will be using is meter per second, right?
Okay, sir.
Yeah.
I'm getting 0.13.
Next time I will check. Okay. 60 by 60. By 0.13.
Yes, sir.
Yeah. So everything is done now. 1 and 2 bits are done. Impeller and diffuser blade angles. Okay. So it is asking, what does it ask? It is asking alpha at the inlet. So it is asking alpha 1 and beta 1. Sorry, at the inlet it is asking, right? So it is asking alpha 2, I think. It is asking alpha 2. Okay. Can you find out? Because you already you have the velocity u, you also have the velocity ca2. Okay, you can find out u at u2 you have ca2. Can't you find using velocity triangles? You can find out, right?
Yes, sir.
Yeah. Based on that, you can solve the bit number 3. Did you understand this type of questions? I think you have become. I think you are able to understand. I think because you are guessing the right formulas. Also, you are able to solve, isn't it?
Yes, sir.
Okay. So now the last question. The centrifugal compressor has an inlet eye of 15 centimeter diameter. The impeller revolves at 20,000 RPM, and the inlet air has an axial velocity of 107 meter per second. CA is given. Inlet stagnation temperature is given, and the inlet pressure is given. Okay. In kg per centimeter square, determine the theoretical angle of blade at this point and the Mach number of the flow at the tip of the eye. Okay. I think you will also be able to solve this question. Just I'm giving you 3 minutes. Think about the approach. Tell me. Otherwise, we'll discuss the approach. I will not solve this question. You take it as your task and you try to solve this question. Okay. Just think for 3 minutes and tell me the approach.
Okay, sir. We also need to find the U1.
Yeah. Correct. So how
So
do
we have
you
the
find out U1?
pi into D1 into N by 60.
Correct. You will find something in meter per second.
Okay.
What are the other things that are given? Axial velocity is given. 107 meter per second.
107 meters per second.
See, one of the things that is given here is nothing else is given. Only temperature and pressure is given. So consider that this is a case of no inlet vents. Okay. Okay. Alpha bar. So can you find out beta 1? Tan beta 1 is equal to CA by U U1.
Yes, sir.
So beta 1 you will get tan inverse of this. So this bit is done. Then the Mach number of the flow at the tip of the eye. Then you have to find out Mach number of the flow. So how to find out Mach number of the flow at the inlet? What is the formula for that? Temperatures is given. Mind that. Stagnant temperature is given. What is the formula for the Mach number?
Maximum fluid flow velocity divided by speed of sound.
So what velocity do you take here? Velocity of sound is correct, but what is the velocity do you take on the numerator?
Yeah.
Huh? Sorry?
I didn't get the numerator. What is the numerator?
Yeah, and the what velocity do you take? Velocity of what? What velocity?
Fluid.
Flow velocity, but that has to be your relative velocity. Okay. So now how to find out V1? when you have beta 1, can you find out V1?
Yes, sir.
What is cos of beta 1?
So, sound beta.
Am I right? Isn't it? Cos beta 1 is equal to U1 by V1.
Yes, sir.
So from here, can you find V1?
Yes, sir. V1 by cos beta 1.
Okay. So you will get something in meter per second. Okay. So this your numerator thing is solved. Now how to find out the velocity of sound? What is the formula for velocity of sound? Gamma
Gamma,
RT.
sir.
Gamma RT1. Okay.
Gamma RT. Okay, sir.
Put over of gamma T1. So we have stagnation temperature at the inlet. We don't have T1, we have T01. How to find out then T1? T1 plus Ca square by 2 is equal to T01. Am I right?
Yes, sir.
So from here, can you find out T1? T01 minus Ca square, sorry, this is TCP. Yeah. Ca square by 2 Cp. Okay?
Okay, sir.
You'll get this in Kelvin. Put that, use R as 287. This is something that you will get. This is 1.4. Okay, you'll get some velocity, meter per second. Okay, now just find out the Mach number. Okay, V1 by 6. Okay,
Okay, sir.
did you understand this question? I think you will be able to solve it. I have written almost
Yes.
everything, just you have to solve this.
Yes, sir.
Okay. So with this, I think all your weekly lectures, weekly interactive session comes to an end. This was a 12-week course. So this was the last course that this was the last week for this course. I think there will be one more course, one more session for this revision for the summary of all IC engine and gas turbine. One course that will be, I think, 2 hours course, maybe on next Thursday. So you will be getting an intimation for that. So don't worry about that. But if there is no such class, so this treat this class as the last class. Okay, you will be finding all the lectures on the YouTube channel. I hope you have subscribed it or you are following the channel.
Yes,
And
sir. Yes.
okay, so and the record and the PPTs and the questions I have already shared on the Google Drive. I hope you have the link of that Google Drive. You will be able to find that for next 1 month. So try to download it, use it whenever you require. And henceforth, if you have any doubt on this course or any of your course which is pertaining to mechanical engineering, I know you are doing your aerospace engineering, but if there is some relation between mechanical and aerospace, some subjects, then you can mail me. I will be happy to answer you. Okay.
Okay, sir.
Okay. Then we'll see in the next class, or if there is a class, which I hope there is a summary class. So I will see. Okay.
Okay, sir.
Okay then. That's all for today.